access modifier. First we'll use an access modifier. Data type, variable name, and size or value. Like this, we'll declare the variable. For example, private int roll number equals 1001. Public string name equals to so like this will declare the variable. Now there are two types of values are there. Value types and reference types. What are value types? What are reference types? What are the examples for these two? And how these value types will work? How these reference types will work? We'll see now. So now, what is value type? So, which holds the value directly? Value types which holds the value directly. Okay. So, for example, int x equals to 10. So means x is holding the directly value. For example, here we'll store like this, x like this it will store. So there will be a specific memory location will be there. Okay, fixed memory location. So this is not going to change. So this is value type. Okay, value directly, which holds the value directly. Reference types, how this will store, which stores the address. For example, here, this reference type, how it will work. This is, there won't be any fixed memory location. Okay, so this is the reference type. Heap, basically, we'll use it, heap memory. And this is stack. For to store the value types, we'll use a stack memory. This first to store the reference type will use a heap memory. For example, if you have a pointer, for example, so how it will be int star x equals to y. So means there are some value, there is a int y equals to 20. There is some value for y. For x also we have to store the 20. Now what we'll do? We'll store the address of y instead of storing value for x. Okay, how this will work? For example, I have a, so this is y value. Y. There will be memory address, right? So here I have 20, and this is my x and x. So for this x, what we are doing? We are storing the y address. So for example, here 03765 something, my memory location. Okay. So this memory location will store here. Okay, means here we are going to provide a reference like this. So this is value type which holds the value directly. This is a reference type. Okay, x is a pointer here, which is a reference type. Okay, so that we are going to store in some other location. Okay, so now what are the value types here? Examples for value types, and this is it stores in stack memory, and this stores in heap memory. Okay. Now, example, we have primitive data types. What are the primitive data types? We have int, float, double, decimal, char, string is not a valid, it's a reference. Data, word, etc. These are all the primitive data types. Along with that, there is one more value type called struct. Struct is a value type, and there is one more value type called enum, enumeration data type. These are all the examples for value types. For reference types, we have string, object, interface, event, array, delegate. These are all the examples for your reference type. So these are value types which holds the value. A reference type which will store the address of the other variable. So it will use a heap memory to store the reference type. Okay. Understood, guys? Any doubts here? So next we have a concept called boxing. What is boxing? Converting value types to reference types. Why this concept came? We know we have a garbage collector, right? How that will work? So the concept of this reference type mainly the memory usage. Okay. Optimization of memory. Okay. For example, if you take this stack memory, so this is one fixed size. Okay. For example, if you create one value type of data, the memory will be fixed. For example, so you have declared a integer, 32 bits of memory will be allocated for this. You declared a long, 64 bits of memory is allocated for that. Okay. So, but here, it's not like that. There won't be any fixed size based on your data, not based on your data type. Based on your data, this is going to occupy. So this memory location, some other thing can't. For example, you took a long here, since it is a 64-bit. So the value which you stored, which is a where 2 bytes will be sufficient. Small int, that the short will be sufficient. Okay. So, but you took a long. Based on the value, that remaining space, memory space, we cannot reuse. Correct. So for that, we'll go for a reference type. This is how this will work. Based on the, there will be entire memory will be available. So wherever free space is there, it will go and fit there. Okay. So there won't be any fixed location. And with the help of this reference type, our garbage collector also will work. How this will work? So it will check for the references. It will run a finalize method. There it will check for the unused references as we discussed yesterday. Okay. So it will check for the unused resources so that it will do the cleanup and it will move to the next generations of those garbage collectors. Okay. So that is the advantage of heap memory here. Okay. And for searching also. Okay. So it will follow that binary tree, all those things. Okay. When we use this heap memory. Okay. Is it clear?
Yes, sir. Okay. So one more question. So in the same memory address, can there be multiple variables stored?
Yes, we can. So for example, if you take, there are some concepts we have in C#, so that multiple values within some memory we are going. For example, if you take a object, for example, if you instance one object, okay, so there will be one memory location will be there in one object. So inside the object, so whatever you have declared in the class, like variables, methods, all those things, it will be there in single memory location, right? So that's how it is going to create. Okay. So further, we'll elaborate more again in coming examples. Okay. So now, converting values types to reference type is called boxing. So for example, what is value type here? For example, I have a integer is a value type. Here we have an object is a reference type, right? Converting value type to reference type. What is value type? Which will be stored in stack memory. A reference type which is stored in heap memory. Okay. Converting from value type to reference type, which is called boxing. So how this will convert? For example, int x equals to 10. This is my value type which is stored in int is a value type. It's a primitive data type. I have object x, object y. Okay. Object y equals to x. This is called boxing. We are converting value type to a reference type. This is called boxing. So next we have one more concept called unboxing. Unboxing, converting reference types to value types is called unboxing. Vice versa. Okay, what this will do, convert a reference type to, what is reference type here? For example, int y equals to 20. Okay, this is reference type. Int x, this is value type. So now how this will work? Int x equals to y. So this is implicit type conversion. Boxing will do implicitly. Implicit type conversion, which will do x to y. Okay. So, but here, when we do the unboxing, converting reference type to value type, it won't do implicitly. It has to do explicit type conversion. Unboxing. We do explicit type conversion. Explicit type conversion. Okay. So how this will do explicit type conversion? Like we have to do the parse. So the destination data type. What is your destination data type? Integer. We have to give it here. So this is one way. Or convert that to int32 or int parse. Anyway, we can do the unboxing. But here we have to do explicit type conversion. So this will happen implicitly, but this will happen explicitly. So a reference type which will be stored in heap memory, value type which will be stored in stack memory. From that type, okay. So not only changing the data type, it has to change the memory as well, right? From reference type to value type. That's why it will do the explicit type conversion. Understood, guys? Any doubts here?
Sir, what will be the real-time example for boxing and unboxing?
This is only we are converting, no?
Okay.
We're converting, right? Int to object. Sometimes we'll convert a string to integer. Okay. So if we get a integer value in a string format, then we'll do convert, right? So same way. So in console application also we are doing, right? Convert .232 to console.read line. That will come in the form of string, then we are converting. That is also unboxing. Then yes. Next. So next what we'll do? We do the control structures. What are the control structures we have in C#.NET? So similarly, like other language, here also we have control
Hello.
structures. Yes, Manish.
Hi, good morning. Yeah.
Manish, go on mute.
Yeah, I already responded.
Okay. So control structures. In C#. So what are the control structures we have in C#? We have conditional statements. In these conditional statements we have if else, if, nested if, loops. We have while, for each. Next we have branching statements. We have break, continue, and return. The next we have the switch case. These are all the control structures or control statements we have in C#.NET. Now let's see one by one how this will work. For example, if condition, how this will work. Let me take one console application. Now, this is my program. For example, here I'll ask user to enter some console.write line. enter age. Allows user to enter his age. Okay. So next, int age equals console dot read line to read the input from the user. So this, once we read it, okay, this will read in the form of string, but here the destination is integer. So we have to convert this, convert dot to int 32 console dot read line. This is how we'll convert. So now we'll check one condition. If age is greater than 0, age is greater than 0, then console dot write line valid age. So what will happen here? For example, I'll enter some age. If the condition is true, condition is matches, condition true, then only it will go the inside of the loop. Suppose condition is fail, we won't get any output. Let's see now how this will go. For example, let me run this. So here we give console dot read or read key. Why this? Because of this, we could able to see the output for longer time. So until unless if you do any key press, till that time it will be waiting for us. Okay. So now let's run this. Into F10. SAS user to enter your age. I'll give 2. Now the age is whatever you entered, it read and it will display the value of your age, which is 2 now. 2 is greater than 0. Condition true. Condition will become true. It will come inside the loop and it will display the output like valid age. Okay. So next, let's run this. Last user to enter his age. He will enter -22. So now -22, age is greater than 0, false. Condition is false. So what will happen? It won't go inside the loop. It will come out of the loop and it will display. We won't display anything because there is no else part here. Only if condition true, then it will display. Condition false, we don't have anything to display. So now, if condition false, then we need something, right? So that particular time we can go for else block. Else. So that's right line. Invalidation, something like this. So now if we enter -1, it will come to else block and it will display the invalid age. Correct. So now else if, for example, I want to check one more condition. Okay. So I want to check one more condition. So let's assume inside this, for example, if it is a valid age, if age is greater than or equals to 18. Greater than or equals to 18. Okay. What will I'll display? The user is valid, eligible for vote, something. The user is eligible for vote when it is greater than or equals to 18. Okay, so this is nested if. So what is this nested if? If inside one more if, that is called nested if. Okay, so now let's see else if. For example, I want to check one more condition here. Okay, so how I'll check this? Else, or let's assume if age is greater than or equals to 16, is senior citizen, the user is senior citizen. Else if age is greater than or equals to 80, the user is eligible for vote. Okay, so here we can give, again you need to check one more thing. You can check one more condition. Okay, so else display. So means user is not greater than or 60, not greater than or equals to 18. So means less than 18, right? So the user is not eligible for vote. Valid user, but not eligible for vote. Now let's execute this. Enter age. I'll enter 22. So first it will check whether user is valid or not. User is a valid user. Then it will check whether age is greater than or equals to 60. No, it will come out of the loop. So then it will check second condition, if age is greater than or equals to 18. So what is age now? 22. It is greater than 18. Condition true. It will come inside the loop and print the user is eligible for vote. Valid age and the user is eligible for vote. Okay. So next. So I'll enter age like 15 or 5. What it will display? So it will check the age, valid age only, but it will come to else part. He is not eligible for vote.